Hey everybody, let's briefly review what we mean by factorial. If n is a natural number, a positive integer, n factorial just means 1 times 2 times 3, and the customary ellipse right here. And then we'll do, let's say, n minus 1 times n. Okay, it's a very well-known definition of factorial. Now we're supposed to determine the largest prime divisor of two factorial expressions. And this is similar to an American Regions Mathematics League problem back in 2012 at the individual competition. Now, something that's nice to notice here that follows from this definition is that 33 factorial. And by the way, folks, what can we do with something like this? Well, normally if we can factor it, at least we can look at potential prime factors. Right now it's hard to look since it's not factored. Okay, but 33 factorial certainly equals to 31 factorial plus the two missing natural numbers, which would be 32 and 33. Okay. So again, from this definition up here, 31 factorial is 1 times 2 times 3 all the way out to 31. And then to make it be 33 factorial, you need to tack on this 32 times 33. Now that comes in handy in terms of factoring this, and let's go down and look at that. We use this fact to actually factor out 31 factorial, okay? So at this stage of the problem, 31 manifestly is the candidate for the largest prime, right? 31 is prime. But the question is, it would be the largest one notwithstanding knowing what this is right here, okay? So 31 is a prime number, and by appearance, there's a possibility it's the largest prime divisor. But we have to take a look at this expression here in the parentheses. And when you simplify this, 32 times 33 minus 1 is 1,055. We got lucky because that's an easily, it's manifestly divisible by 5. Okay, so what we get right here is 31 factorial. And this one isn't too hard to do in your head. This would be certainly 5 is a factor of 1,055. And then so you have 5 times 211. Okay, 5 times 211. And y'all notice the question becomes, is 5's not bigger than 31, but 211, if it's a prime, will be our answer, right? Well, all we really have to check, you guys are familiar with the 211 is certainly less. What's the first? 13, 169, 15, 17. Okay, this is less than. Let's see. We need. Okay, 211. It's less than 225, right? Or excuse me, the square root. I'm talking about the square root, right, folks? The square root of 211 is certainly less than 15, right? So why did I do that? Well, there's a result that says all you have to do is look at the prime divisors of the square root of 211 that are less than, the square root of 211. Okay, well, this is a rough upper bound. So really all you have to check here are the prime numbers 2, 3, 5. Now you can see already that these 211 is not divisible by 2, 3, or 5. Remember, there's a divisibility test. 2 plus 1 plus 1 is not divisible by 3. There's a divisibility test for 7 that says you take 2 times this, the last digit, and subtract it. That would give you 19, which is not divisible by 7. Also, there's a divisibility test for 11. All right, that says you just alternate signs here. So you'd have 1 minus 1, which is 0, plus 2. So this is not divisible by 11 either. And then it's not divisible by 13. Now, there's not really a nice test that I know of for 13, but 13 does not divide to 11. And so we've checked all the prime divisors. None of these prime numbers divide to 11, so that means that 211 is prime. 211 is prime. And it's larger than 31 or 5. 211 is a prime number. So that's the answer to the question, folks. 211. Now, just just a comment, you might think, well, gosh, 33 minus 31, that's just 2, right? But 33 factorial minus 31 factorial turns out to be close to a 40-digit number, right? So if you don't have some sort of factoring schemes here, you're not going to figure this out. You know, it's really, I think it's maybe a 38, 37-digit number, okay? But this factorial factoring scheme, along with getting lucky right here, you know, if this wasn't immediately divisible by something, it was a large number, then you got to work quite a bit to determine if it's prime or whether or not it has prime factors. But the fact that it was divisible by 5 made an easy check for this 211. So 211 is the answer. I thought it was a cool problem. Thanks for reading.